Hello and welcome to this video on conic sections. This is going to be a short video just based on one conic section, the circle, and it's going to be in three parts. First, I'm going to describe what the graph of a function like a circle means. Like, what do you mean when you give an equation and say this equation represents a circle? The second is actually deriving the equation of a circle, and the third is one short sum. We're going to try and solve a single sum. So let's start. So to kind of start off with that, what you have to do is remember that essentially any geometric figure, two-dimensional geometric figure, whether it be a circle or a parabola or an ellipse or even a straight line, all of them are graphs of functions. Now, what do I mean when I say it's a graph of a function? So you remember the Cartesian coordinate system, right? With x-axis and y-axis stretching on both directions, both negative and positive coordinates. So when you say something is a graph of a function, what it means is that this two-dimensional figure is made up of a series of points, right? Like the circle, for example, is made up of an infinite number of points which all have their own coordinates, and that can be represented in this system. Okay, now I understand this is getting a bit complicated, so I'll start off with a really simple example. Think of the simplest equation that you know. Let's say we start off with y is equal to x plus 1, a very simple function, right? Sorry about that. Now this line is the graph of the function y is equal to x plus 1. Now think about what this represents. The Cartesian coordinate system is a standard. You can give this function to me and I can reproduce this line wherever I am without knowing anything else about this line. So essentially this is the function which represents the line. And so that is what I mean when I say that a two-dimensional figure is a graph of a function. So if you want to let someone else know what the two-dimensional figure is, what you do is you give them the function. I'll give another example. Let's start off with another function. Let's say y is equal to x square. So for x equals 0, y is 0. For x equal to 1, y is 1. For x equal to 2, y is 4, x equal to 3, y is 9, and so on. And it is the same on this side. So what you get is you get a graph which goes like this, and which is a curved line, and this is the graph of the function y is equal to x square. Now if I want to reproduce this exact line in some other part of the world, all you have to do is you have to give me this function. You have to give me the function y is equal to x square, and I'll be able to reproduce this line, this curved line. Now that's the power of functions, right? And that's what I mean when I say a graph is a function. Now what I gave were really simple examples, like just a straight line or one simple parabola, but the same holds true for even more complex figures like a circle. So how do we get the equation of a circle? Let's say you have this circle here represented in 2D Cartesian space. How do you find out the function which represents this circle, like I was talking about earlier? So a circle, as you know, is a set of points equidistant from a fixed point known as a center, equidistant with the length of radius called r, right? So to go about doing this, let's represent the center by the coordinates h, k as per convention. So the center is represented by the constants coordinates h, k. They're called constants because they do not change, whereas these points are variables in the sense that they are around the circle, so they are represented by the coordinates x, y, meaning x and y change according to which point in the circle you're talking about. Now, how do you go from this to actually describing the equation of the circle? The answer lies in one of the most basic theorems in mathematics, the Pythagoras theorem. Let's see how. So this radius can also be represented as the hypotenuse of this right angle triangle, right? Now if you remember the Pythagoras theorem, let's say the hypotenuse is C and these sides are A and B, we know A square plus B square is equal to C square, right? And that's exactly what we're going to do. So C square is R square. And how do we get the length A? Remember, the coordinate of this point, the x coordinate of this point is x as well, x and something. And in order to get the length of this line segment, what you simply have to do is subtract h from x, since this is parallel to the x-axis. So the length of this line segment A is x minus h, and in order to get the length of y, a similar rule applies. Since this is perpendicular to this and parallel to the y-axis, in order to get the length of b, what you do is you simply subtract k from y. So the length of b is y minus k, and that is the equation which came from the Pythagoras theorem. X minus h the whole square plus y minus k the whole square is equal to r square. Now think back to what I told in the previous section. If you give me this function, I can represent this circle exactly without you telling me anything else about the circle. And that's what we mean when they say the circle is a graph of this function. Now let's move on to actually solving some of the problems as it appears in the NCERT textbook. Now when you get a question like this, find the center and radius of the circle represented by this equation. So how do you go about solving this? So what you have to always remember is, when you get an equation like this, try to reduce it to some form of x minus h the whole square plus y minus k the whole square is equal to r square, where you know the center is hk and the radius is r. So how do you begin to simplify this? Well, 2x square plus 2y square minus x is equal to 0 can be divided by 2 on all sides to simplify to x square plus y square minus x is equal to 0, right? Which can then be rearranged to be written as, half x equal to 0, right? Which can then be rearranged to be written as x square minus half x plus y square is equal to 0. Now think back to our expansions. A minus b the whole square is equal to a square minus 2ab plus b square, and a plus b the whole square is equal to a square plus 2ab plus b square, right? Now what you have to understand is this is an incomplete expansion of this. So by adding some term on both sides, it can be reduced into this, and this is similar to the form we want, right? So it is x square minus, so how do you change this into some form of 2ab, where a is x and b is another constant? It's 2 into, so how do you get half by multiplying something with 2? It has to be 1 by 4, right? By 4 into x, where x is our a and 1 by 4 is our b, plus b square, which is 1 by 4 the whole square, plus, well, y square is essentially y minus 0 the whole square, is equal to, since we added 1 by 4 here, 1 by 4 the whole square here, we have to add it here as well, is 1 by 4 the whole square. Now this, since it's the form of x square minus 2ab plus b square plus this can be reduced and written as x minus 1 by 4 the whole square plus y minus 0 the whole square is equal to 1 by 4 square. There you have it. X minus h the whole square plus y minus k the whole square is equal to r square is the equation of a circle whose center is 1 by 4, 0, and radius is 1 by 4. So that's it for this video. I hope this was able to help you in some way. If you like it, leave a thumbs up or leave a comment. Thank you.